In this video, we'll first start working on converting scientific notation numbers to decimals. And I'll give you a big tip on the problem you're working on right now. Let's get this pen to work. Alright, now we have three numbers in scientific notation. You've got this number here times some power of 10. Now this is to the second power here and to the eighth power here. Going back to this one, what's the power here? Well, the 1's implied, isn't it? This is 10 to the first power, just 10 itself. Now, I have the 1.3 over here for each of these, and the thing about it is, if for every power of 10 you multiply this by, you've got to move your decimal point 1 to the right, don't you? So this is just 1.3 times 10. Now you know that's 13. The way I'm going to show you to do it is this way. Take that and move that 1 to the right. And your decimal number is 13. Here we're doing 2 tens, aren't we? This is 1.3 times 10 times 10. So let's take this and move this 2 to the right. I do it this way. I put a 0 right there. 130. So here's going to take more moving. 8 times, huh? So here's how I do this. I go 1, 2, 3, 4, 5, 6, 7, 8. And I fill in every little spot here with a 0. See if I did it right. Go back and count. 1, 2, 3, 4, 5, 6, 7, 8. Sure. And let's see. A comma's going to go there, right? I'll put the comma up top. Kind of crowded. A comma's going to go here. So our answer is going to be 130, 0, 0, 0, 0, 0, 0. That's 130 million. Easy enough? The way I do it is take every power of 10, move it over for each power. 1 there, 2 there, and 8 there. Now, it's not necessary in this problem, but let's just do the other way too. This is a negative 1. Here you take that and go 1 this way. This is going to be 0.13. 2 of them, 1 and 2, put a 0 here, 0.013. And here's the big one. 1, 2, 3, 4, 5, 6, 7, 8. I got room. 0, 0, 0, 0, 0, 0, 0. So 7 zeros. 1, 2, 3, 4, 5, 6, 7, right? So that's going to be 0.0, 0, 0, 3, 4, 5, 6, 7, 1, 3. Okay? So that's how scientific notation works, and you'll need that in the problem you're working on. You'll need this kind here. Now the last thing, this actually comes from the problem you're working on. This is a classic example of how the blue sheet method is your friend. If you use it, you'll get this problem right. If you didn't, you would just be floundering around probably and you'd end up guessing. Let's read this. When astronauts land on the moon, radio signals. Now first of all, radio signals. What are those things? Those are electromagnetic waves. Don't you know their velocity? I'm not going to give it to you. It's on your green sheet, isn't it? You had that velocity, so you should fill that in. You've got it. The waves took 1.3 seconds. That's time. You're asking for distance. Now, isn't this a simple problem now? Find the formula, fill it in, and get the answer. The only trick is going to be you're going to have to actually do this probably before you actually do your math. I don't think you want to do math with a scientific notation in your formula. I don't think you want to do that. So you probably got to do that first. And then, as you can see, you've got your velocity from your knowledge of EM waves. I'm not going to give it to you. You have the time, you have the distance, and you should have one of your simple formulas and figure it out. Piece of cake, right? Alright, so let's see, we saw your video code, didn't we, back here? It's psi notation. S-C-I-N-O-T-A-T-I-O-N, psi notation. And use these two techniques and you'll get this problem right. Bye.